Now we come to the logical channels. When we talk about the logical channels, basically we can divide the logical channels into two main branches. One is the traffic channels, as we discussed earlier, and other are the control channels. And in the control channels are basically necessary for the signaling between the mobile station and the BTS, or the mobile station and the network. And you very well know that no mobile network can operate without the signaling. It is the most important thing in a mobile network. And then these control channels are divided into three types. One is the dedicated control channels, one is the common control channels, and the third one is the broadcast channels. And now we talk a bit more detail about the broadcast channels. Broadcast channels are basically downlink channels, and broadcast channels are necessary so that a mobile can find a network, synchronize with it, and connect to it. And these broadcast channels are further subdivided into three types of channels. One is the frequency correction channel, or FCCH. Other is the synchronization channel, or SCH. And the third one is the broadcast control channel, or BCCH. And now how these control channels are mapped on the on our frame structure, or on the frequencies that have been allocated to a BTS. The broadcast channels and the common control channels are normally mapped on the first time slot of a of the first TRX of a base station. Now, in this case, we have a base station which has three TRXs, or in other words, it can handle three ARFCNs. So, for the first ARFCN, the first time slot in the uplink and in the downlink is basically where we are mapping our broadcast channels and our common control channels. And how all these channels are mapped on to a single time slot. And also you must keep in mind that when we are mapping our broadcast channels and common control channels on the first time slot of the TRX number 1 of a base station, then in that case we can no longer use this time slot for traffic channel. This means that the maximum number of subscribers we can handle on TRX number 1 are 7 in this case, instead of 8, which is the normal case. Now we come to the question that how these channels are mapped on the first time slot. So these channels are basically mapped on the first time slot in a time multiplexed mode. And what do I mean by the time multiplexed mode? This means that, for example, this is the first time slot of the first frame, okay, and then here is the first time slot of the second frame of the TRX1, and then it's the third frame and its first time slot. Then I will have the fourth frame, and then I have its first time slot, and then I go up till the 51st 51st frames first time slot. So all the first time slots of the 51 frames are basically drawn here. This means that I am basically drawing the control channel, or the channel on which BCH and CCCH are mapped here. And this structure basically repeats itself after 51 frames, and I call this a control multi-frame structure which consists of 51 frames. And these are all the first time slots of the 51 frames of TRX1 which are multiplexed. And here it's the first time slots in the uplink of the 51 frames, and here they are the 51 time slots in the downlink. Now here I can see that in the first time slot of the first frame I have the frequency correction channel, and in the second and in the first time slot of the second frame, I have the synchronization channel. And then in the first time slot of the third, fourth and fifth frame, I will have the broadcast control channels. And then in the first time slot of 6th, 7th, 8th and ninth frame, I have the common control channels. And I can very well see that the frequency correction channel or FCCX repeat after 10 frames. This means that they repeat in the first time slot after 10 frames. And similarly, the synchronization channel also repeats in the after 10 frames.
So this is known as the control multi-frame structure, consisting of the first time slots of 51 frames, which repeats itself after 51 frames.
Control our multi-frame structure. Now we come to the question that how these broadcast channels are used. As I mentioned earlier, that basically broadcast channels are essential so that a mobile station finds a network, synchronizes it with it and connects with it. So how it is done? First of all, whenever you power up a mobile, it will always look for the first time slot of the first TRX, and this frequency is also known as the broadcast ARF signal. So what this mobile will do, that it will try to measure the power on the first time slot of the first TRX of this base station, and then also the first time slot of the first TRX of this base station, and whichever base station's first time slot power it finds higher, it would try to connect with that base station, because it is this mobile station is receiving maximum power from that base station. So after a mobile station has determined that which base station has the best coverage for it or the highest power is received from which base station, in the next step what this mobile station will do, it will basically lock onto the frequency correction channel. And why it would lock onto the frequency correction channel? Because in the wireless systems, frequency and the phase synchronization is very important between the transmitter and the receiver. So in this way, mobile station will synchronize its phase and frequency with the help of frequency correction channel. And once it has achieved that synchronization, now it is possible to perform the coherent demodulation. And in the second step, it will basically synchronize itself with the SCH channel, because the carriers frequencies and phase have been synchronized, but now it's the time to synchronize the frames in the time.
It is only after that the decoding of the information that is there in the first channel possible. So when the mobile station synchronizes itself with the synchronization channel for the time synchronization, then it also gets the frame number and the base station identification code from the synchronization. After that, it would try to decode the broadcast control channels.
Channels, and we can very well see that the broadcast control channels or BCCX are mapped on the second, third, fourth, fifth and sixth time slots of the 51 multi-frame. And what information does this broadcast control channel give? The information that it gives is that it tells the mobile station about the network identity, what is the identity of this cell, and also what is the location area in which this mobile station is located, and also what are the frequencies that are in use in this base station as well as in the neighboring base stations, so that whenever handover is required, the mobile can do the handover. Like this mobile is moving towards that base station, so the mobile requires this information for the handover, that what frequencies are used in the neighboring cells. And there are some other informations also which are basically broadcast in this. So this is this all these three channels are basically helping the mobile station to find a network, identify a network, synchronize with it, and afterwards to connect with it using the common control channels. So now we come to the functionality of the common control channels. Basically, common control channels are those channels which are used by the network or the mobile station by the network or the BTS in order to connect to a mobile station in case there is an incoming call for this mobile station, or they can be used by this mobile station to connect to the BTS in case this mobile station wants to register itself with the network or it want to start a call. So this is the function of common control channels, and this is a common pool of channels which in a cell which can be used by the base station or the mobile station. Now there are two types of common control channels. One is in the uplink direction. It is the random access channel, and random access channel is basically mapped on the first time slots, all the first time slots of the 51 multiframe. This means that the first time slot of TRX1 in the uplink direction will basically carry the random access channel in the 51 multiframe. And in the downlink, the channels that you have as the common control channels are the paging channel, access grant channel, and the common broadcast control channel. And when we see the control multi-frame structure, we can very well see that these common control channels, these three common control channels, are basically mapped on the first time slot of TRX number 1 on the frame number 7, 8, 9, 10, 13, 14, and so on. So now the question comes that how these common control channels function. Now, for example, this is a mobile station and there is an incoming call for this mobile station in the network. So this BTS will use the paging channel or PCH to page or inform this mobile station about the incoming call. And this mobile station will respond using the random access channel to acknowledgement the receipt of this call, and and then the mobile will use the access grant channel to assign a standalone dedicated control channel to this mobile. What is standalone dedicated control channel? We will come to it later on. And then whenever, for example, there is a case that the mobile station wants to register itself with the network or it wants to initiate a call, it will access the base station using the random access channel, and the base station will respond on the access grant channel. Now, what is the function of common broadcast control channel? The function of the common broadcast control channel is that, for example, there is some broadcast message for all the mobiles in a cell, then BTS broadcasts that message for all the mobiles in a network using the common broadcast control channel. Now we come to the functionality of the dedicated control channels. Dedicated control channels are called exist in the uplink and the downlink, and these are called dedicated control channels because they are assigned by the network, and once they have been assigned between a base station and the MSC, then they are point-to-point channels that they will only use to carry the signaling between the mobile station and BTS in the uplink direction and the downlink direction. Now, as we talked earlier, that the common control channel and the broadcast control channels are assigned on the first time slot of the TRX number 1. But on the contrary, the dedicated control channels like the TCH channels can be assigned on any time slot except the time slot number 1 of the TRX number 1. Like, for example, they can be assigned on the TRX number 2 on this time slot, on the third time slot, or they can assign be assigned here, or they can be assigned here, depending upon different times. A dedicated control channel can be assigned on a different time slot. And now there are three types of dedicated control channels. One is the standalone dedicated control channel, other is the fast associated control channel or FACCH, and the third one is the slow associated control channel. Now, what is the function of standalone dedicated control channel? And when standalone dedicated control channel is assigned, normally the standalone dedicated channel is assigned just before the assignment of the TCH, and TCH which is used for the transfer of voice or the data. So, for example, in this case, this is a mobile station which wants to initiate a call with the network. So, it will access the network on the RACH, or radio access, random access channel, and then network will respond on the access grant channel, and it will assign a standalone dedicated control channel to between this mobile station and the BTS, and this is a duplex channel in the uplink as well as in the downlink. Now, when a mobile wants to connect to a network, then the network has to verify whether this is a valid network user or not, and this verification procedure is done by the MSE, and the signaling that is carried out between the mobile station and the BTS, and then this signaling information is actually the is also communicated with the MSC, that is carried on the standalone dedicated control channel while the user is being verified whether it's a valid user or not. And then once that verification procedure is completed, then a TCH channel is assigned to it so that the user can perform its normal voice or its data communication. And now then we come to the fast associated control channel. Fast associated control channel is very similar to the standalone dedicated control channel, but it is used in in those cases where we don't have a dedicated standalone dedicated control channel. And what do I mean by that? For example, this mobile station is in a call with this BTS, and they are communicating on the TCH channel, and this means that there is a normal call going on, voice call going on between this mobile station and this BTS. And now suppose, for example, this mobile station is moving towards this BTS. In that case, the power it is receiving from this BTS is continuously decreasing, and the power it is receiving from this BTS, it is continuously increasing. In this case, basically this mobile station has to perform a handover from this BTS to this BTS, and basically the handover commands and come from the BSC. So, in order for the signaling that is required for the handover procedure between the mobile station and the BTS cannot be carried on the TCL. So, what will happen that this TCH channel will temporarily change to the fast associated control channel. This means that your normal voice communication will stop, and that TCH channel that was carrying that voice communication will now convert to the fast associated control channel. And over this fast associated control channel, basically this BTS will inform at the proper time to this mobile station to switch over to this BTS and disconnect from this BTS, and that's how the handover procedure will be completed. So now we come to the third dedicated control channel, which is the slow associated control channel or SACCH. Again, it is a duplex channel. But one important thing to keep in mind is that slow associated control channel is only assigned when a mobile station has been assigned a TCH channel for an active call, or it has been assigned a standalone dedicated control channel. Furthermore, this SACCH information or SACCH channel is not a separate channel, rather it is multiplexed with the TCH channel. And how it is multiplexed? It is multiplexed in this way. For example, a mobile station has been assigned, is in active call with the network, and it has been assigned as a TCH channel. And this TCH channel has been assigned on the third time slot of TRX number 2. Now if this is the first frame of TRX number 2, this is the second frame of TRX number 2, then 26 such frames of the TRX number 2 will form the speech multiframe of 120 millisecond. And this, if this is a full rate channel, this means that this time slot RTCH has been assigned uniquely to this mobile during the duration this mobile is in call with the network. In that case, in the 13th frame, and it's the third time slot of the 13th frame, actually the SACCH information in the uplink from the mobile station to the BTS will be transmitted. And similarly, in the downlink 13th frame of the TRX number 2, and in its third time slot, the downlink SACCH information will transmitted from the mobile station to the base station, while the 26th frame will be the idle frame, like nothing will be transmitted in the uplink or the downlink in the 26th frame. Now, and this is for the case when we have a full rate channel assigned to this mobile station. Now, in case this mobile station has been assigned a half rate channel, this means that there are two mobile stations that have been assigned on the same time slot or the same TCH in the third time slot of TRX number 2, but they are using this time slot in the alternative frames. So in that case, what will happen, that in the third time slot of the 13th frame, first the SACCH information of the first mobile will be transmitted to the base station, and similarly from the base station to the mobile on the downlink side. And then in the third time slot of the 26th frame, the SACCH information of the second mobile will be transmitted from the mobile station to the base station, and then in the downlink side from the base station to mobile station in the third time slot of the 26th frame. So this is the case for the half rate TCH channels, that how their SACCH information is transmitted. Now we come to the question that what actually is this SACCH information. So in the uplink direction, whenever a mobile is in active call with the base station, basically it is measuring the power it is receiving from this base station as well as from the neighboring base stations, and it is transmitting this information to the BTS and then to BSC, so that BSC can analyze this information, whether if this mobile station is moving from this base station to this base station, whether its power is increasing, its power is decreasing, if there is a need for handover or not. And similarly, this mobile station is also sending in the uplink direction the information that what is the how many bit error rates are there on the TCH channel it is using, or what is the TCH quality. So this information is also important for the network, if there are too many bit error rates on this TCH channel or not, and this information is also sent in the uplink direction. And these two information, received signal strength and TCH quality, are sent from mobile station to the base station after every 120 millisecond, because the duration of this frame is 120 millisecond. And this information is known as the measurement report, and measurement report is very important for the base station, because it decides that when to perform the handovers, and also in the it decides that how far is mobile station from the base station, and also it decides when it's how to control the power of these, transmit power of these mobile systems. So in the downlink direction, what information is being carried from base station to the mobile station in the SACCH, in the form of SACCH information. First one is the power level instruction. Like if this mobile station is near to the base station, then in that case it is not necessary that this mobile station transmits at a very high power and causes unnecessary interference to other mobile stations which are using same frequency. So base station instructs this mobile station to transmit at a lower power. And similarly, if this mobile station is away and its communication is not, its proper signal strength is not receiving at the base station, this BTS will be instructed to transmit at a lower power. And this information is carried in the SECH frame in the downlink diagram. Similarly, there is another information which is known as the timing advance information. We will come to in detail to timing advance, what is timing advance in some later lecture, but the important thing to keep in mind is that, for example, a mobile station has been assigned the time slot number 3. Now it is important that this base station receives the communication of this mobile in this particular time slot. But if a mobile station is away from the base station, then in that case it is possible that its communication is getting delayed. So in order to properly synchronize this communication between the mobile station and the base station in the uplink direction, you have a timing advance parameter that is being transmitted from the base station to the network, so that it can either transmit its communication how much earlier, so that when it reaches this base station, it is in its proper time slot. So in the uplink, so in the downlink direction, the how much adjustment the mobile station has to make in its communication is instructed by the BTS in the form of the timing advance information.